Hello friends, this is Sai. Now I am discussing about the concept of VLSI design flow. This VLSI design flow is the basic interview question which was asked by every VLSI company. Those who are struggling to get the job in the VLSI core industry, follow my video lectures until the end. At the end of every video lecture, I will tell some of the interview questions which was previously asked by some of the semiconductor companies. Solutions will be explained in the next video lecture. So be careful and keep in touch. Let's get started. For the typical VLSI design flow, we are followed 11 steps. Step 1. Design specifications. In any design, specifications are to be written first. Specifications mainly describe abstractly the functionality on the interface and overall performance or architecture of the digital circuit to be designed. At this point, the architects has to be not need to be think more about the implement of the digital circuit. Step 2. Behavioral description. Behavioral description are often written in HDL. HDL stands for Hardware Description Language. In some companies they will be used VHDL, and some companies they will be used Verilog. The main purpose of the behavioral description is explained in terms of performance, functionality, and the higher level issues. Step 3. RTL Description. From this point onwards, the process of EDA tools has to come. EDA stands for Electronic Design Automation. Mentor Graphics has the EDA tool. Cadence has an EDA tool, and some companies has to be their own EDA tools. In this step, the designer has to be describe the data flow that will implement the actual digital circuit. Step 4. Functional verification and testing. Functional verification is the task of verifying the logic design conforms to the specification. This functional verification testing is very difficult to do because, for example, we are taking a simple circuit. For the simple circuit also we are writing number of test cases. If we are take complex digital hardware circuit, it will be make sure that we have to write many more test cases. That means it will be 1,000, 10,000 about test cases. That will be so hard task. But this functional verification testing is very important task. The entire coding has to be done by means of UVM or OVM. UVM stands for the Universal Verification Methodologies designed by the Mentor Graphics. Step 5. Logic synthesis or timing verification. Logic synthesis tools convert the RTL description to a gate-level netlist. In this logical synthesis, tools ensures that the gate-level netlist, whether it may be meets required timing or not, whether it have take the sufficient power or not, all of these specifications has to come here. Step 6. Gate level netlist. In gate level netlist, the description of the circuit in terms of gates and how it will be connected between from one circuit to another circuit or one component to another component. Step 7. Logical verification and the testing. In logical verification and the testing, the usage of CAD tools has to be required. CAD stands for the computer-aided design. By means of different algorithms, that means T algorithm and the Bodem algorithms or automatic test pattern generations. Mainly this work has to be done by the DFT engineers, digital function testing and the testability engineers, as well as STA engineers, whether the circuit has to be getting their required range or not, whether the circuit has to be tested very perfectly or not. Step 8. Floor planning automatic place and route. Here, these all of terms are come from the physical design. Physical design is also known as semi-custom design. In physical design, it will be deployed into floor planning, placing and the routing, and the different things will be there. Mainly the floor planning means it will be you have a circuit. It will be a sliceable, that means cut it into the vertical and the horizontal lines. You have the placing means whatever the digital circuit you are taking, whether it may be have the limited size or not, and the routing has to be designed. It's exact design wiring to be connected. Step 9. Physical layout. After completing that floor planning, routing, place and the route, we will be go to the physical layout. Here we can actually represent the geometric representation of the shapes of the required design. Step 10. Layout verification. This layout verification is also known as full custom design. For this, mainly we have to check for the LVS, layout versus schematic, and the DRC, design rule check for the cadence tool. For the mental graphics tool, it will be an different softwares will be there. And finally, whether the circuit has to be matched or not for our required layout. And next, finally, step 11, implementation. Now we have to combine all of these steps. We have to move on to the implementation stage. In this implementation stage, this is your final stage. Your chips will be manufactured or fabrication has to be done. This fabrication has to be done in very cool room, and the dust has to be not come. And as well as some of the fabrication companies like TSMC, Global Foundries, and Size and Winpackers, and the companies will be there which will mainly fabrication has to be done. These companies will be there in the US, Germany. Here the overview VLSI design flow. We are discussing about all of these 11 steps. If any error has to be come in the RTL description, that means it will be in the same way only. That means this arrow mark has to be shown in the same position only. Whether the design engineer has to be checked where the errors will be there or where the bugs will be there. Next, whether it will be moved from functional verification and texting from RTL description. Here, in functional verification and testing, any error will become it will be go to the RTL description, and in logical verification and the testing, any error will become, it will be code to the RTL description. That means whatever the code we are writing in terms of VHDL or the Verilog, by means of the design engineers, they will be checked where the bug will be there. And next, here in layout verification, any error has to be come. It will be go to the floor planning automatic place and the route. Then the bug or the error has to be removed. Whether the bug or error has to be not removed means directly it will be go to the RTL description. That means the bug or error will be there in the code only. That means RTL code. If you have any doubts regarding to this video lecture, I hope that you ask in the comment section. Thank you guys for watching.